Hey guys, welcome to an introduction to electrical circuits, where we will discuss what a circuit is, the schematic symbols you will see in a circuit diagram, types of circuits, both series and in parallel. We'll also have a brief introduction to Ohm's law with examples, as well as examples on how to measure and read current and voltage on circuit diagrams. So to start, we're going to talk about the cell. So the cell stores chemical energy and transfers it to electrical energy when a circuit is connected. A cell has two ends labeled positive and negative. A cell pushes the electric current from the positive terminal round to the negative one. This is the way that conventional current flows. We always think of electric current as a flow of positive charges moving from a positive to a negative. This convention started before the discovery of the electron and the realization that electrons carry current in a circuit. Two or more cells can make a connected end-to-end to make a battery. Typical cell has a voltage of 1.5 volts. We write this as 1.5 V. By connecting cells in series, we can make batteries with 3 volts, 6 volts, and so on. Each battery is labeled with its voltage. This tells us about the push it gives to make the current flow. For example, a 6-volt battery gives a bigger push than a 1.5-volt cell. A cell or battery can push an electric current through a circuit to a lamp. The bigger the voltage, the bigger the push. A bigger push gives a bigger current and the lamp shines more brightly. So what is electric current? An electric current is a flow of microscopic particles called electrons flowing through wires and components. In which direction does the current flow? From the negative terminal to the positive terminal of a cell. So all electric circuits have three main parts. One, they have a source of energy, or the power source. Two, they have a closed path, or the wires. And three, they have a device which uses the energy, also called the load. If any part of the circuit is open, the device will not work. Here's a simple electric circuit. It has a cell or power source, the load, which is the lamp, and a switch, as labeled here. To make the circuit complete, these components are connected together with metal connecting wires. When the switch is closed, the lamp lights up. This is because there is a continuous path for the electric current to flow around. If there were any breaks in the circuit, the current could not flow. Engineers draw electric circuits using symbols. Symbols such as the power source, the load, the switch, and the wires, as shown in this diagram to the right. To understand circuits, you need to be able to draw what they look like using a set of standard symbols understood anywhere in the world. For the battery symbol, the long line is considered the positive terminal, and the short line is the negative. The voltmeter and ammeter are special devices you place in or around the circuit to measure the voltage and current. So the battery symbols are noted here. You can see the positive and negative. And then the ammeter and voltmeter symbols would be drawn as such. You also have several other symbols that you must know. So at this time, I would like you to take out your notebook and draw these symbols. So we have power source, battery, switch, load, a buzzer, ammeter, voltmeter, a motor, resistor, and variable resistor. You'll notice that resistor and variable resistor have two different types of symbols. You will see both listed on electrical diagrams. There are two basic ways to wire a circuit. One way is a series, which is one after another. And you will see from the positive to the negative in series, two different bulbs. And the other is parallel, so in between a set of junctions and parallel to each other. In series circuits, you have one path for current flow. The total voltage equals sums of drops across all loads. The total resistance equals sum of resistance of each load, and if one bulb blows, it breaks the whole circuit, and all the bulbs go out. So again, important to remember that the total voltage equals sums of drops across all loads, and then the total resistance equals sums of resistance of each load. So before we get into figuring out current, voltage, and resistance, we have to understand an important law, which is Ohm's law. Ohm's law is the relationship between resistance, current, and voltage in electrical circuits. This law is one of the most important concepts to master in the field of electrical engineering because it will be used more than any other. Ohm's law was named for a 19th century German physicist named George Ohm. He discovered that if he kept resistance constant and varied voltage, dividing the voltage by current always equals resistance. This formula can be used to solve any of the three variables. And you can see here, R equals voltage divided by current. You also have current, or I, equals voltage divided by resistance. And then E, which stands for voltage, equals I current times resistance. So take a second to write this down if you are not familiar. So let's look at an example. So example 1, let's say you want to calculate the resistance of a flashlight bulb. You know that your batteries are providing 3 volts and you are drawing a 0.1 amp of current flow. Using the formula R equals E divided by I, we're going to draw this as 3 volts divided by 0.1 amps equals 30 ohms of resistance. Example 2, a series circuit is shown to the left, and we're going to answer what is the total resistance. So the first thing that we have to do is we know that resistance on this type of series circuit is the total all the way across. So we're going to go with 1 ohm plus 2 ohms plus 3 ohms equals 6 ohms total resistance on this series circuit. So what is the total current? So using Ohm's law, we are going to figure out current, which is I. So I equals E, which is the volt, divided by the resistance. We just figured out what resistance was, which is 6 ohms. We know what the E, or the volts, is according to the diagram, which is 12. So I equals 12 divided by 6. So I is going to be 2 amps. That is the total current for this example. So what's the current across each resistor? So as we discussed previously, in a series circuit, the total current equally across each resistor. So that means in this example, each resistor will get 2 amps. And then finally, what's the voltage drop across each resistor? So we're going to apply Ohm's law to each resistor separately. So first we're going to do volts equals 2 times 1 equals 2 volts. That's for the 1 ohm resistor. For the 3 ohm resistor, it's going to be 2 times 3 equals 6 volts. And then for the 2 ohm resistor, we have 2 times 2 equals 4 volts. So again, you're using Ohm's law to figure out the voltage drop across each resistor. And when we're figuring out voltage, voltage equals E. Notice that the individual voltage drops adds up to the total voltage that is across all the circuit. So 2 plus 6 plus 4 equals 12. Parallel circuits have multiple paths for current flow. The components are connected side by side. The current has a choice of routes, and if one bulb blows, there is still a complete circuit to the other bulb, so it stays lit. The total voltage equals voltage across each branch. The total current equals sum of the branch currents, so it's a little bit different than the series circuits. So let's look at an example. Okay, so let's look at this example 3. So we know that we have to add the total resistance across all of the resistors. So how we're going to do that is we're going to make those into decimals. So it's going to be 1/5. So that's 1 divided by 5 comes out to 0.2 plus 1/7. So 1 divided by 7 is 0.1428. Then we have 1/9, which is 0.111. We add those together, it comes out to 0.454. So now we have to divide that. 1 divided by 0.454 will equal 2.20 ohms across each resistor. So what's the total current? Again, we're using Ohm's law. So V equals I times R. 8 equals, and we know R, so it's going to be 8 divided by 2.20 equals 3.64. What is the voltage across each resistor? And so we know that it is shared. So for this one right here, it's going to be 8 volts. That's the voltage across each resistor. And then what is the current drop across each resistor? Again, we have to use Ohm's law. And so you can see the calculations here. So the first one is the 5 ohm resistor equals 8 divided by 5. It's going to equal 1.6 amps. The second is going to be the 7 ohm resistor equals 8 divided by 7. Comes out to 1.14 amps. And the third is the 9 ohm resistor equals 8 divided by 9 comes out to 0.90 amps. Again, we're using Ohm's law. So take a second, try some of these out yourself. See if you come out with the right answer. If you're still confused, ask your teacher and they will be able to explain it to you further. Notice that the individual currents add to the total. So if we add 1.6 amps up with 1.14 amps with 0.90 amps, it will come out to the 3.64 amps. Electric current is measured in amps using an ammeter connected in series in the circuit. So when we're looking at this example here, we can see that if we're going to be doing a series circuit, our ammeter is going to be placed between the power source and that first load. And if we're doing a parallel circuit, we're going to be placing our ammeter between the power source and again, that first load in our parallel circuit. So measuring current is the same at all points in the circuit. So if we're doing current, it's going to be 2 amps across, for this example, 2 amps across every single line or wire. If it's a parallel circuit, it's shared between components. So you can see here, when we get down to the parallel circuit, we take that 2 amps and we divide it in half, come out with the 1 amp between each. So let's look at an example. So copy the following circuits and fill in the missing ammeter readings. So go ahead and take a second, press pause on the video, copy this down into your notebook, and then try to figure it out, and then come back and see what the right answer is. So you can notice here the first one is a series circuit, the second one is a parallel. Remember, in series circuit, the amperage is the same across all wires. In a parallel circuit, the amperage is going to be divided. So go ahead and take a second to write that down. Okay, guys, welcome back. For example 1, the series circuit is going to be 4 amps across all areas. And then on the second parallel circuit, you can see it's 3 amps, which is going to be where it's where it's still a series, and then when it comes down to parallel circuits, it's divided in between all three of those parallel circuits, so it's going to be 1 amp each. The electrical push which the cell gives to the current is called voltage. It is measured in volts on a voltmeter. This is an example of what a voltmeter looks like, and this is an example of what the symbol will look like. So different cells produce different voltages. The bigger the voltage supplied by the cell, the bigger the current. Unlike an ammeter, a voltmeter is connected across the components. Scientists or engineers usually use the term potential difference, PD, when they talk about voltage. This is how we draw a voltmeter in a circuit. So that you can see on the series circuit, we're going to be across them, not with the circuit. And then the voltmeter on the parallel circuit is very similar. So remember, when we're measuring voltage across a series, we're going to be going across that circuit, and it is shared voltage. So whatever this total voltage on that circuit is, it's going to be shared between each of those areas. So for example, if we're looking at a series circuit, the voltage is shared between the components. So you can see here on our 3-volt circuit, when we come down and we measure our voltage across our loads, or those X symbols, you'll see that they're going to be 1.5 volts. Now, in a parallel circuit, it's going to be the same. So voltage is the same in all parts of the circuit. So in the series circuit, it's shared. In the parallel circuit, it is the same. And so when we're looking at this example, if it's a 3-volt circuit, it's going to be 3 volts on both of those shared circuit areas. Okay, guys, now we've come to the practical exercise. So measuring current and voltage. What we're going to be doing is you are going to be copying the following circuits on the next 2 slides. You're going to complete the missing current and voltage readings and submit to your teacher, however they have instructed you to. Remember the rules for current and voltage in series and parallel, and good luck. So here's the first one. So we can see that this is going to be in series. And so we have our voltage as 6 volts. We have our amperage as 4 amps. And so you can see the areas that you need to calculate for. So go ahead and copy this down. Press pause if you need to. And then our second practical exercise is going to be a parallel circuit. So you can see that our voltage is 6 volts again. We have a 4 amp amperage, and you can see the areas where you will need to calculate for. So guys, that concludes the video for today. I hope you guys have enjoyed the video. If you have questions, please ask your teacher, and have a great day.